Hello, friends, and welcome to episode 4 of our monthly Structural Basics series, where we talk about structural engineering, my journey creating content online, and my life as a structural engineer. This is a January update. I got a new haircut. Look at this weather. It's 14 degrees here in Munich. Sun's out, everyone's happy. In these monthly series, we cover one story of the month, one structural tip of the month, and then an update on structural basics, what we have been building the last 4 weeks, numbers, growth stats, and so on. Now, let's get into it. Let's start with the story of the month. Today, I want to give you an introduction to the platform Structural Basics. Most of you found me probably through YouTube or by a blog post that you found through Google. But I structured the website structuralbasics.com in a way that you can easily find related topics. Yeah, we have over 100 structural engineering related articles on the website. So let's start the computer and let me show you guys how we structured structuralbasics.com. Okay, so first up, how do you actually find the blog? If you can't remember, if you have been on the blog a couple of months ago and you don't know anymore, so you either simply, yeah, type in Google structural basics, and then I should, or like the blog should pop up here at the top, and you click on this, or you directly just type in structural basics.com, and then the blog pops up as well. Then yeah, how did I structure the whole thing? Like, I have this homepage where I have a couple of things, like some nice images and what the blog is about, or the website. Then you can sign up for the free weekly newsletter here. Then the introduction of this monthly Structural Basics series, and then what a couple of you guys are saying about Structural Basics. Yeah, and then just a quote I lived by and some of the most popular articles. But then, yeah, then we have basic. Then the next thing is that at the top we have blog, statics, loads, structural design, about, and other. Blog, that is just simply like all of the blog posts that I've written by the publishing date. So the last article I published on the blog is basically at the top. You see here November 30th, October 31st, October 14th. But it's not easy to navigate. If you're looking for a specific topic, you can see we have 12 different pages here. It's much better to look for, like, if you're interested in structural design, go to structural design. If you're looking how to calculate the dead load or the wind load, then you probably should look here on the loads, and let's simply look into those categories here. So statics, again, I have written like what this is about. Statics and mechanics are the basics of structural engineering. And then if you are really new to structural engineering, you should start with statics, because that's the fundamentals and the basics of structural engineering. And I made it even easier for you to get started, because I said step one, you need to learn about what statically determinate and indeterminate means. And here's the link, you can click on it, and then an article pops up. I also made a YouTube video about this. You can also check this one out. But then step two would be, to understand what type of loads act on beams, then reaction forces, and how to calculate internal forces. And again, there's always like articles behind those buttons here. But then, of course, we have a lot more articles, like arch structures, how you calculate bending moments of arch structures, trusses. Then we have some cheat sheets like beam deflection formulas, rigid frame formulas, continuous beam formulas. Yeah, and then here's some geometry cheat sheets that's also kind of in this category of engineering mechanics and statics, like moment of inertia of an uncracked reinforced concrete section, polar section modulus, how to find the centroid of a cross section. Yeah, this is this stuff. And then loads. Again, a quick introduction, why we need to calculate loads and consider them, what loads are, and then we have a lot of articles here, how to calculate dead live load, peak velocity pressure, wind loads, even wind load calculation on an arched roof, snow load, the different types of loads in buildings, and then uniformly distributed loads, point loads, and what load combinations are. Yeah, so you can find all kind of load calculation guides here. And then structural design, that's probably most interesting for most of you guys. I categorize like under structural design, again, we have a couple of different sections like reinforced concrete, timber, steel, and masonry. But yeah, we have a bunch of articles here. And if you have been subscribed to the newsletter, yeah, you know that we have written a lot of articles about reinforced concrete in the last couple of weeks. And I'm trying to also upload them here on the blog, but right now I'm super busy. But yeah, just try to have a look here. You find a lot of stuff and guides here. And then of course we also have geotechnical and foundation design, strip footings, pad footings, timber design, how to design timber beams, columns, purlins, rafters, then steel design, yeah, how to design butt welds and fillet welds, and then masonry design, shear walls and point loads. Yeah, and then the last thing is basically, like, we also have the other section. We have some book notes where I summarized some technical structural engineering books, and we also have some product reviews and digital tools. If you click on here quickly, we have a guide on a free beam calculator, how to use how to use Scanniverse. It's like a 3D LiDAR scanning app. Shortcuts to boost your productivity, Notion, and how to get started with LaTeX. Bunch of stuff there. And then we have the about page. And that is just simply for you if you're interested in me as in my personality, or like in my background and where I come from, what I've done in the past. That's the page where I try to summarize everything. And you can simply read it. Here's also some structural engineering stuff, what I've been working on. Yeah, but that's all about the platform structural basics. I think there's a lot of stuff, and I wish I had such a resource, which is so practical when I was in uni studying structural engineering, because I never understood how you connect like a simply supported beam to actually like a concrete beam. How do you get from the internal forces to the finished design on the construction side? And that's basically my goal with the site and with the YouTube channel, to kind of close this gap between theory and then practical structural engineering stuff. And I hope some of you understand it a little bit better. It's very difficult, but I'm trying my best here. Okay, let's get to the structure tip of the month. This time I want to cover the 3 equilibrium equations. And that's one of the first things we learn about in our first semester in our structural engineering bachelor's. First thing we need to know about them. So we use them to calculate reaction and internal forces, like bending moments, shear forces, and so on. But we can only use them for statically determinate structure. structures and systems. I'll leave a link to an article where I explain the difference between statically determinate and indeterminate structures. The three equilibrium equations, they consist of horizontal equilibrium, vertical equilibrium, and moment equilibrium. And what that means is basically for horizontal equilibrium that the sum of all horizontal forces equals 0. Right? I'll show an example later on. Then the vertical equilibrium is the sum of all vertical forces. And the moment equilibrium, the sum of all moments is 0. And yeah, let's try and see what that means for an example. So we have a very simple structure here, like a simply supported beam supported by a roller and a pin support and exposed to a line load of 2 kilonewton per meter, and the span is 4 meters. How do we use these equilibrium equations now? So the first step is step 1, to calculate the reaction forces. So they are here. We have a vertical reaction force and a vertical reaction force here. We call this AV and BV, V for vertical. And then the pin support also has a horizontal reaction force, which is AH. Okay, so in step 1, we calculate the reaction forces. Let's do that. We first say, okay, vertical equilibrium, so the sum of all vertical forces is 0. How does that look like? So we have our two supports, AV plus AB, and they are in the same direction. So that's why we add them. But then the line load is in the opposite direction. That's why we subtract that. So we have 2 kilonewton per meter times 4 meters equals 0. But now we have two unknowns, AV and AB, so we cannot solve this equation. So that's why we need another equation. But let's first do the horizontal equilibrium, which is sum of all horizontal forces equals 0. And here we only have AH as a horizontal force or load. So that's 0, and therefore AH equals 0. Now we have one more equation, and that is the moment equilibrium. And we have to choose like a location for that. Let's say we do it in point B. So moment equilibrium in B equals 0. So what do we have? We have AV, and we say this is the positive direction. So we have AV times 4 meters. We don't have an ABV because it's in the point where we do moment equilibrium. And then we have our line load, which equals, we subtract that, so 2 kilonewton per meter times 4 meters, but then only half the distance times 4 meters divided by 2 equals 0. And now we can see we only have one unknown, and that is AV. So we can solve that actually for AV. So we say, okay, we divide that, we say we divide that by 4 meters. So then we have AV minus 2 kilonewton per meter times 4 meter divided by 2 equals 0. Now we say plus 2 kilonewton meter times 4 meter divided by 2. And we can solve AV, and that equals 2 kilonewton per meter times 4 meters. That is 8. So then we have 4 kilonewton for AV. And now we can also solve BV because we have AV. So this equation here is AV. Sorry, we know that. So 4 kilonewton plus BV minus 2 kilonewton per meter times 4 meter equals 0. Now let's do this down here. We solve it for BV, then we have BV equals minus 4 kilonewton plus 8 kilonewton, because this one here is 8 kilonewton. Yes, and that is BV equals 4 kilonewton. Great, so we have BV, we have AV, and we have AH. So we calculated all reaction forces. Now in step 2, we can calculate, okay, this is really messy, I'm sorry for that, but it's the first time we try this format. In step 2, we can calculate internal forces. Right. Such as bending moments, shear forces, axial forces, and again with the equilibrium equations. Let's do it for this beam. We say internal forces. We have our beam. We do a cut here at 2 meters. We have our reaction force AV, and then our moment, our shear force, so moment, shear force, and then usually we have a normal force, but that's 0, so we leave it out for now. And basically we can do exactly the same again. And one thing I forgot is we also have to add our line load. Again, we can do vertical, horizontal equilibrium. In this case, we have AV minus V minus 2 kilonewton per meter times 2 meter, because we cut at 2 meters. And then we can solve the shear force. This equals 0, so we solve it for V, and then we have AV equals 4 kilonewton minus 2 kilonewton per meter times 2 meters, also 4 kilonewton. So AV is at this location 0, and then moment equilibrium equals AV times 2 meter minus 2 kilonewton per meter times 2 meter times half the distance, which is 2 meter divided by 2. And then minus moment equals 0. Now let's solve that for the moment. AV is 4 kilonewton times 2 meter is 8 kilonewton meter minus 2 kilonewton per meter times 2 meter times 2 times 1 meter equals 4 kilonewton meter. 2 times 2 is 4, yes, equals 0. Sorry, not equal, but this means that our moment is 4 kilonewton meter. All right, so that was it. It was very messy, and let me know in the comments if you like this type of calculations here on the iPad. Um, but I hope you maybe understood, yeah, the three equilibrium equations a bit more. Okay, next update on structural basics. As of today, January 25th, we are 11,161 structural engineers subscribed to the Structural Basics newsletter. We had about 35,000 people visit our homepage, structuralbasics.com, in the last 30 days. And on YouTube, we have grown by 337 people in the last 28 days. And we are now 2,850 people subscribed on our YouTube channel. This is the biggest month in terms of YouTube growth so far, which is great to see. On the newsletter, we have published 5 articles, and the topics were calculation of the lap length of rebars, deflection analysis of reinforced concrete elements, how to digitize your hand calculations, and the strut and tie method to design reinforced concrete elements. Sorry, I first said 5 articles, it was actually 4. And I'll leave links in the description below if you want to check those articles out. Yeah, that was it for January. I hope you got value. I hope you return. And I see you in the next one in February. Peace.